Indicate which part of your hand represents the current direction. So it'd be the fingers.
Yeah. Well,
Yeah.
it would be the middle finger though, because Lorentz
right here?
force is the thumb.
Oh, okay, so this would be
The current direction.
current direction, yeah. Your fingers indicate the current direction. Click on the part of the hand that indicates Lorentz force. Lorentz force direction. Your thumb indicates, okay. Switch the circuit on. In which direction is the Lorentz force acting?
Sir, you don't have the little blue lines.
Yeah, where are they at?
Well, to answer that question, it's gonna be left.
Left. But it didn't show the lines.
It's supposed to. I don't know why.
That's weird. Yeah, that one didn't show up. See, even this one's not showing up. Okay, well, if it says the polarity is reversed, it should go right.
Yeah.
So does that mean your palm will always face the south magnet?
Left.
Your palm. No, the palm is your magnetic field, right?
Right. So the magnetic field always goes from the south magnet to the north.
To the north, yeah.
Okay.
Is this supposed to be moving or something? 'Cause it's not doing anything.
Left.
I don't know. It's not doing anything to mine either, but I just checked it and it's supposed to be right.
Right. I think it might be glitched out because I'm pretty sure it's supposed to have some type of movement on there.
Yeah.
So the magnitude of the Lorentz force depends on the size of the homogeneous magnetic field, B in Tesla. The size of the current through the electronic conductor in amps, and the length of the conductor in the magnetic field in meters. So the formula used to calculate Lorentz force is FL, which stands for Lorentz force, equals B, which is magnetic field in Tesla, times I. So amps and meters. So the definition is as follows. Lorentz force is the force that exerted in a charge by the electromagnetic field. Using
No,
the slider.
restart.
What?
Restart.
Using the slider, you can change the strength of the magnetic field. Okay, so let's do that. Okay. What happens when the magnetic field gets larger?
The Lorentz force
Decreases.
increases.
Increases, right? Because it's moving?
Mm-hmm.
Correct. All right. So you can change the amount of current using the slider. So now we're changing current. So you can change. Okay, what happens when the current increases? So Lorentz is increasing as well, right?
Yes.
Yeah.
Okay, so both are increasing. So they're more than likely proportional. What happens when the length is increased? What are they changing? The length of what? Oh, the Lorentz force or what?
Yeah, it's still increasing.
So everything's increasing, right?
Mhm.
Increases. That's why everything's being multiplied. So using the polarity button, can you change the direction of the current? Okay, let's change the direction. What do you see when you do this? The conductor moves in
conductor
the other direction. So what does the Lorentz force depend on?
All three: the
Yeah.
size, the length, and the magnet.
Everything. What is the definition of Lorentz force?
Lorentz force is a force exerted on a conductor by an
Electromagnetic field. Correct. So calculate the
That's the one
following
I'm stuck on.
situation in terms of Lorentz force. B equals
That's the one
2.
I was talking about.
Okay.
Same.
But John was right. So if you look at this, it says, so the formula would be FL, wait, hold on. FL equals B times I times I. So you would
Well, it's
have
actually L. B-I-L.
BIL, okay, BIL. It's weird.
Very.
So then we got 2T times I, which is 5 amps, times L, right? You said?
Yeah.
Which is 10 millimeters. But we have to convert millimeters to meters, right?
Yeah.
They're trying to talk this entire goddamn time. My mic has been up.
Yeah, I was off. So it's 0.01.
Oh my god.
So it's actually 2 times 5 times 0.01. It is 0.1.
Yeah.
0.1. Yep, there it is. Yeah,
Oh
so
yeah,
that
because
was the
you
problem.
have to convert it now into what, meters?
2 meters,
Something?
yeah, because up here it says the length of the conductor and magnetic field in meters.
Yeah, that's what I was doing, and I was like, ah, shit, I got the question wrong, and then I read meters. I'm like, oh, never
There,
mind.
yeah. So that's a little tricky, and it's the thing about this is Electude is actually a universal based system, and they use a lot of the metric system. So you won't see inches, you won't see stuff like that, or feet. You're gonna see meters, millimeters, and centimeters. But yeah, John was correct. You do have to convert it to millimeters to correctly get the correct answer on this one. But yeah, that was tough, and that's the stuff we were having with my transmissions class, is that there was a lot of tricky little questions where we had to find out either the formula, we had to do a little bit of conversions until we were able to get all the correct stuff to be able to actually do it. Uh, Another thing that I told the guys on my transmission class is, well, I'll show you right now after we do this. Was that the only part that you were stuck in?
Yeah.
Did you want to go through
Keep
the rest
going.
or keep going? All right, let's keep going. So the electric motors use the Lorentz force, alternators, and electric solenoids do not work without the force either. So we place a conductor in the shape of a loop through a permanent magnetic field. And this is going to apply to motors, starter motors, pretty much almost everything. At the end of the loop, the current passes in a different direction. These Lorentz forces ensure that the motor begins to rotate. If the winding arrives in the horizontal position, it will come to a stop. The Lorentz force acts outwards. By reversing the current in the conductor, you ensure the conductor will continue to rotate. So the direction of the current is indicated. Using the left-hand rule, determine the direction of the Lorentz force at the top and bottom. Click on the arrows, so it'd be here,
No, the other one, the top left hand,
this one.
and then yeah, the bottom right.
So that is your rotational force then.
Yeah.
So it's rotating towards to the left,
Yeah, isn't that
right?
counterclockwise?
Yeah, counterclockwise. So now let's switch the current by pressing the button. Okay. What happens?
The winding
It-
rotates 90 degrees.
90 degrees. Can we reverse the polarity? Oh no, he can't. It doesn't let us do it yet. Change the direction of the current by pressing the polarity button. So we're gonna turn it on. All right, let's reverse the polarity. So all it's doing is changing the rotation of the actual force.
Yeah.
The windings rotate the opposite direction. What happens if you reverse the current several times? Turn it on.
It changes 180 degrees and a random.
Yeah. Yeah. So it'd be a random direction, 180 degrees. That's right. So later on, well, I don't know if it'll show you here, but the way they get the starter motors to work and motors to work is they add more of these magnetics on the side, like the north and south poles, so it can actually continue to rotate depending on where it's at. And that's why I kind of like the brushless motors, because you have a lot of individual solenoids or coil packs, so you can have a lot of fluid motion. Has anyone ever heard of a stepper motor? Stepper motor?
Stepper motor.
Yeah,
Nope.
Yes.
stepper motor, not steeper. Uh, these stepper motors. The reason I know them is because I do 3D printing, and on the printer they have stepper motors. These little motors. Let me just show you a little picture of them. These guys right here
Oh,
have,
okay.
yeah, they have many directions that they can go. They can go, rotate clockwise, but their precision is extremely good. They
Isn't that
use,
like the
what's up?
CD players or something?
The which ones?
Like the CD players?
Yeah, kind of like that. But on these, they're like extremely accurate. They use a lot of these stepper motors and bigger ones on manufacturing plants. Tesla. Let me see Tesla.
I would use those little motors to make
Uh-huh.
like tattoo machines.
Oh, really?
Yeah.
That's awesome.
And I would be selling them at school.
That's crazy, man.
Everybody
Over
like
here.
fucking shitty ass tattoos.
There is a picture right here. The cool thing about these step motors is they're able to be programmed very efficiently and very precisely. Can I just open this? Well, if you can see this, because I can't really open it up. This is a Tesla manufacturing plant. These robotic arms, they're all controlled by stepper motors, and if you can see, it's kind of hard to see. Let me see if I can zoom in. Nah, it doesn't let me zoom in. Can I open this picture? There it is. So if you look at here on top, these are stepper motors. All of these are controlling a different type of angle, pretty much, because these robotic arms move all over the place because these guys are completely assembling the Tesla motor. I mean, the Tesla vehicle, which is pretty cool. So, like I said, motors have gone through a lot of renditions and they've gone through many technologies. And I think the newest and latest system that I've seen is a stepper motor, which is pretty much a brushless motor, but it has a computer to indicate the position of where the motor is going. Of course, you don't really need this in a starter motor, in a fan motor, an engine fan motor, because all it does is it rotates in one direction and one direction only. That's it. But on this, since this is a controlled arm, this arm can move up, down, left, right, diagonal. It does everything you need to do by a program. So it's pretty interesting, but that's pretty much what you see in new style uh, electronic motors. It's pretty cool.
Hey Siri, you were the one that said that Electu doesn't time out, right?
It shouldn't.
It did.
Like it kicked you out or what?
Yeah, I had to log in again. Like not right now. This was like a few days ago.
Did it let you start off where you left off or no?
Yeah, but if you did something and it logged you out, it
Mhm.
completely forgets what you put on there.
Oh no. Well, I mean, if you already gone through it once, I mean, it shouldn't be too bad to go back in.
Yeah,
But I
every
didn't
time
know
you
that.
check, it saves.
You should save it, right?
Yeah.
All right. So why does the winding stop in the horizontal position?
All three.
All three. The Lorentz forces are in equilibrium. The Lorentz forces are both pointing outwards because the current continues to flow in the same direction. So let's check out both. Check. That is right. So you have not finished this lesson. You can go back to the previous page when you're ready. Okay, so
Let's take the test now.
That quiz is literally the easiest thing.
the quiz or what?
Yes, the quiz is so easy.
Oh, I didn't mean to do that.
I have a question on the electric motors.
Okay, we'll go right there. We'll go in there right now.
What do you want now, Steven?
So the
Bro,
quiz,
just-
y'all take that quiz. Electric motor on this one right here.
The electric motor, permanent magnet motor.
Permanent magnet. All right. So a permanent magnet motor, PM motor, uses a permanent magnets. This motor is often used in starter motors, which we've gone over, wheelchair motors, and cordless drills. No field windings are used in the construction, therefore permanent magnet motors are typically a smaller and more energy efficient. Permanent magnet motors are not always suitable for large capacities. This is because the strength of the permanent magnet is limited. That said, new magnetic materials have been developed which are several times stronger. Where might you find permanent magnet motors? Okay, well it said starter, cordless, wheelchair, not a washing machine. What source of magnetism do these motors use? They use the permanent magnet. I think it's Earth's magnetic. No, not Earth. Permanent magnetism.
What's an earth magnet field?
Like an actual magnet. Like have you ever had a magnet on your hand?
Yeah.
Okay.
That's an Earth magnet. It's actually like a material that is actually
The most common one people know
magnetized.
is called magnetite.
Magnetite.
It's the most common one.
Yes, the magnet is tight.
Oh my god, what a dad joke.
I'm sorry. I think I'm hanging around my dad a little too much.
Wait, you have a dad?
No, not for you.
Damn.
Bro, that hit
Hey,
Yeah.
look at
for
that
me.
mom.
Yeah,
You know,
like
that's
these
a good
would be
question.
considered an earth magnet. Just a piece of material that's actually magnetized naturally.
Don't worry, man. I never met my real parents. I was adopted.
Hey, boy.
My Ted, my dad told
Your
me at
dad.
H. My Ted. I just woke up. Leave me alone. My dad told me at HEB when I was 10, I was adopted. I started crying the whole time I was at HEB.
Oh no.
God damn, son.
No
And
matter
then my
what,
mom got,
you
and then
have to tell your
my
child
mom
that
got
they're
mad at me.
adopted.
Jeez.
My
You
dad's
have
still out buying cigarettes and never came back.
Oh no.
to.
Jeez.
God.
There was a
Oh,
meme out there where you know how like they were making fun of like the dolphins coming back and all that stuff coming
yeah.
back.
Oh, the black kid's dad.
Yeah,
Oh, oh.
that was so fucked up. I was like,
Yeah.
oh no. Day
Man.
My dad.
675, the father comes back like ching. Oh man, that's so fucked up.
Oh no,
Okay,
dude.
we all got something.
Dude,
Yeah, dude.
my friend was playing For Honor yesterday,
Mm-hmm.
and he's good. Like he's actually pretty good. But he was playing with his friends, and some of them are retards. So they lost, they lost, but they barely lost, and the other team was really trash. So they invited him to the party, so he joined, and it was a bunch of black guys.
Uh-huh.
And they were just talking a bunch of shit. And then when my friend was like, "Ah, well, I don't have no purpose here anymore," so he's like, "What, Dad? All right, I'll be there in a bit." He left the party. I'm like, "Ah, dude,
Jeez.
that's a little fucked
That's
up."
fucked up.
Oh no.
¿Qué pasa?
I know, dude. That's fucked up.
Oh yeah, yesterday I was playing Plunder duos, right?
Yeah.
Very start of the fucking mission, my ally leaves.
Good job.
So you're by yourself?
Yeah, I still proceed to get first place at 1.4 million.
There you
Shit, that's fucking
freaking
good.
go, man.
I
That's
did
awesome.
a total of 9 contracts with Point Man as one of the perks. That gives
Bam.
a fuck ton of money.
It is, man. That's badass.
It's
We're
like
playing Oh, go ahead.
It's like 1.3 or 113,000 per contract completed,
Fuck, dude, that's badass.
and then during overtime it's 2.6. Scary shit, dude.
Damn. That's awesome. I was playing Apex Legends last night with my buddies. And we've been playing ranked and we just jumped from silver to gold. And we had 2 fucking wins in gold rank. I was like, alright, that's not bad. It's pretty good. We're really surprised, but I love that game, man. It's so much fun. Plunder's badass too. I like Plunder. But you need to have a good team, man. If you have like randoms sometimes it just doesn't work. Like the good thing about my buddies in Apex is it's just consistently me, him, and my other buddy, and we're always on the same page. So it helps a lot. When you play with randos, it's very difficult.
No, you never want to play with me. I freaking always leave. Like I
Oh
don't
no.
care. Like last time I was playing, and we're playing Smite,
Mhm.
and my mom calls me. She's like, "Hey, I'm out of work. Can you pick me up already?" I'm like, "Oh yeah, for sure." And I left, and I didn't tell the guys because I'm like,
Uh-oh.
"Well, I have to go pick up my mom. My mom's more important than them, right?" So I came back. I'm like, "Oh, what's up?" And then I see in my thing when I log back in, it's like if you continue this thing, you'll get permaban from this game.
Oh
Like,
damn.
what the fuck? And
Yeah,
I
dude.
joined. My friend texted me. He's like, "Bro, everybody banned you, or everybody reported you." I'm like,
Fuck.
"Fucking fake friends, man."
That sucks.
And then I reported them, and
At that point, you
one of
gotta
them,
disown them.
one of
Oh,
them actually
no.
got banned from talking to on Xbox Live through party chat. So I felt
That's
happy.
funny. Yeah, you gotta be careful, man. Especially like these ranked ones. You gotta make sure you're there, or else they will kick you out, or they ban you for a short period of time because.
That's why I play casuals.
Okay, yeah, that's true. That helps. That's pretty funny though, man. Oh, I know. But I mean, that's what I do. I usually do homework from when I wake up till 5 or 6, and then I'll
I
load
do
up.
homework until I feel satisfied. So if I feel satisfied after the first question, I'm done.
What?
Indeed.
One question. All right, that's it for today. We'll pick this up.
The complete opposite. I don't do homework. I wait till I know
no.
it's the last day, last
Do you-
minute,
You
and I
procrastinate.
do it. Un
No,
chingazo.
I do my homework till like 7, and then I head to my grandma's. Since my grandma lives like right behind us,
That's cool. Yeah, my
so
grandma lives actually next door too.
yeah, I just go through my backyard through the freaking like alley sort of,
Mhm.
and then to her house.
There you go. Get
And
some
I
grub
just
and then come back.
yeah. Well, I here over there. I just spend time with my little cousins, so
That's cool.
it's
That's
fine.
the only way, man.
Yeah.
Yeah,
I should probably go visit my grandpa, man.
There you
He
go.
lives like 2 houses away, and I don't even.
my grandpa lives in a shed in our backyard.
Oh,
Bruh.
as long as it's badass shit.
Yeah,
But
he
yeah,
has a bunch of shit in
it's
there.
cool, man. Like I was telling everybody, just try to make your time efficient, man. Because honestly, if you're like who's that earlier? I heard him right now.
That's a good question.
Brian. I heard Brian. Brian likes to do everything at the last day.
Hey,
I used
man.
to be like that,
If it
but
works, it works, you know?
don't waste time. So okay, let me ask you this: what do you do with the remainder of time that you have?
But what do you mean?
Okay, well, like what do you do? Like okay, you're not doing
That's his
homework,
time
so what
for
do you
her
do?
to attack.
That's a good question. That's a really good question. I can't fully answer that question,
I need
but
to
no,
reflect on that question, so I'll be
it's
back.
it's logical and fun.
Now, I mean, if you're working, okay, that's understandable.
No.
But if we're not, so what do you do with the time?
I'm basically just living my life, man. Just chilling. You know, the time that I could spend doing homework, I spend over there. If you can probably hear, you might hear the music that's
Yeah, I
playing.
can hear it.
I can
Yeah.
also hear the gunfire.
What gunfire?
It's
He's
pipeline
like,
games.
what?
Hold on, son. No, it's because my parents are over in the freaking sala and we have a big speaker, so they're always
Oh, okay.
jamming.
That's cool.
Most likely in a few minutes, they're gonna come to try and get me to dance over.
There you go.
That's
You gotta
what we
make the
do
best
all
of
day,
it.
man. Exactly. If I was doing homework, I couldn't go and dance.
That's true, but you'll be expanding the knowledge.
I would,
Uh,
but
Don't.
I can also finish it last day.
The thing about doing everything last minute is you're not gonna remember it.
Yeah, you're right. I forgot a few times.
So what I do is I work on some stuff little by little every day because you'll remember it from yesterday, remember it from the day before, and you'll slowly start to build it up. Now, yes, I've done a couple of times where okay, I'm gonna finish it all one day, and I do it, badass done. And then when I have a test on next week, I'm like, okay, what the fuck just happened? I forgot everything because you don't practice it. If you don't practice it, you're gonna forget it.
So that's what happened.
Yes, that's exactly what happens because I'm taking a class, and yeah, sometimes I actually just okay, I'm gonna finish everything one day, so I can just play games and just relax. And then next week comes in, and we're like, oh, we're taking a test over 9, 10, 11. I was like, fuck, what the hell did we learn? And it sucked.
Nothing.
Exactly because I forgot everything already. So that's the tough. But
So even in general, whenever I do things on time, I don't retain anything.
no, well, it's because we need to practice it. That's the hard part. The practice is where we retain the stuff.
But even then, like the stuff that we're not actually allowed to test on in person,
I
like
know. That's the
you
hard part too.
can't.
That's the hard part. Um, that's why I try to go over like a schematic almost every time we meet because if you see schematics more often, you'll actually kind of understand what we're looking at. Now, I hope we understand how a schematic looks like, and I hope we understand where the power is at and where the ground is at and what components look like and
Wait, what's
what.
power?
Oh no. We did go over the SI schematics, right? We went over that together.
I don't think so.
Did we or no?
No.
I thought we did. Hold on, I'll put this on pause. Let's look at it really quick because, like I said, I do want to look at schematics as
Oh,
much as possible.
is it on like chapter 3 or 4?
I think so. Yeah,
If it is, then I think we did.
I think we did. This one right here.
Yeah, we did.
We
You
did,
told
right?
us that it
Okay.
was gonna be for like practice, not as a
Yeah,
grade, and everyone
and-
was so worried.
So yeah, I think we a couple of days after we went over it.
Yeah.
The only thing I don't think I did with you guys was the component locator. hopefully we know how to do a component locator.
I mean, we kind of can't. We don't have access to it.
Yeah, that's the only thing. I know there's a STC one, but sometimes it doesn't work, and sometimes it's not gonna have the correct information that you're gonna need, especially for that job sheet. So pretty much what we're left with is Electude, and it works for what it's designed for. You know, a supplemental system for learning the automotive industry, but it's not going to be a substitute for any type of hands-on training. So let me jump into this really quick because let's look at something that we would have been doing right now in class in the actual lab, and that is a starter circuit voltage drop. So if you look at this, this would be one of the job sheets we'd be doing if we were in class right now. And what is the purpose for a voltage drop, first of all?
What is what?
What's the purpose for a voltage drop? Like, why do we do voltage drop?
Good
Make
reason.
sure everything has the correct voltage it needs to run.
Yeah, you're checking the actual circuit that's providing the current or the ground to the component, your starter motor, pretty much in this case. So a voltmeter measures the difference in electrical pressure between the test leads. So when the meter leads are connected to two locations and the engine is cranked, the meter will display the difference in voltage between the 2 points. This difference is called a voltage drop. So now if you look at here, if you look at this model, I want you to study this. Where are we checking this circuit from? Here to here. Where is that checking?
From ground to the negative lead.
Yeah. So your ground from your battery to your ground, either your chassis or your engine block, depending on where it's at, right? And we're gonna go over that right now. On this one, where is this one going to? This one right here.
Jesus.
The ground?
The ground's this side. We already
no.
discussed that
To
one. What about
the
this one right here?
solenoid.
Okay, yeah. So this one is going from your power, which is directly from your battery, all the way to my starter solenoid to the connector right here. Now, this is just an illustration. Let's look at an actual schematic, because you're not going to have an illustration like that when you're working alpha. You're going to have a schematic, and you need to do the actual test. So, can anyone give me a example vehicle? Has to be a GM though, and we'll check it out.
99 Chevy Tahoe.
99 Chevrolet Tahoe. Let's check it out.
Hey, I'm gonna get some rims.
Oh yeah, what kind are you gonna get?
I forgot the name.
Deep
I'll
dish.
show you a picture.
Yeah, send the
they're
pics.
coming.
Badass, man. Are you getting like for like mud terrains or all terrains?
Based on 32s. Nah,
Oh,
baby. Nah, they're
32s,
16.
32s are good.
They're 16 off-road wheels.
Badass. I have 20s on my truck, but I want to get either 17s or 18s with some 34s or 35s.
Yeah, I kept telling them, but they're like, they don't fit. I was like, man, I'll fucking make it fit. Just
They'll
put them
make
on.
it
Like,
fit.
they won't fit. I have a fucking grinder. I could fucking cut it.
Yeah, there you go.
Hey, where
Yeah,
can
I
I
can do
find
this.
what's it called? Drag tires.
Probably Summit Racing. I've never purchased drag tires before, so I'm not too sure.
Jegs. I
Jegs
think they're
also,
like
right?
$300 or $200 each.
Not
The
for
fucking my friend bought some fucking some slicks for his Camaro.
Yeah.
How much?
Is
How
that-
much were they?
Like he paid like $253 something
Each,
like
right?
that. Yeah.
Yeah, they're expensive.
Because I might want to buy some for the Ford in the back.
That's
Like he
bad.
bought the little rim for the front, a little tire, and
Mhm.
the fucking slicks.
Nice.
I'll put a picture on here later.
Damn, the jams are going.
Yeah, más que hacer.
Alright, so let's look at this. Insert PDF. It's on my desktop. It is called the starter. Open. Yes. Insert. Is that it? Bad man, Majama.
Oh God,
Damn.
I muted.
All right. So if you look at here, let's go back to our job sheet. Let's say I had you guys in class and I gave you this job sheet and I told you guys, look, we need to do this. And it is right. Let's take this off. You're already piling up too many stuff. All right. So we're working on this job sheet. Start a circuit voltage drop. It says disable the ignition system or fuel system to keep the engine from starting. Okay, so let's do this first. Disable the ignition system or the fuel system to keep the engine from starting. All right. So we also need to go to another schematic. So where would I find my ignition system or fuel system for my schematics? So this is SI. This is my engines. Where would I find a schematic to disable my ignition or my fuel? On this page right here.
Probably engine controls.
Yeah, so let's go to engine controls. Let's look at schematics. And let's see. I would say engine
Probably base
controls.
electric.
Yeah. So now out of these, which one would you find? Either your ignition or your fuel.
Ignition controls, fuel controls, or fuel injector controls.
Which one you want to check out? Number 3, number 4.
I'd probably say 4 because you only need to
Four.
stop the injectors from putting fuel
From
in.
Hey,
shooting.
Vega.
Yeah. What's up?
I think my truck fixed the fuel thing.
What was it doing?
Remember how it didn't work, right?
The
On the dash.
Oh
The
yeah,
light.
yeah.
But I filled it up again like 3 days ago,
Mhm.
or on Friday. And pues le faltaba like, it looked like it had like, 'cause I put 25 gallons and it holds 30 gallons.
Mhm.
So it still had 5 gallons left. And it was like right there, like maybe 5 gallons on the thing. I guess it's
So
probably a
you
fix.
think he well, I would be careful, man. Don't realign it yet
Yeah, 'cause
because
I did it again. I drove 300 miles and then not like straight right, but 300 miles, and then I filled it up with 25 and it still had 5 gallons left.
oh, that's not bad.
Yeah. So I'm still keeping an eye on it.
Yeah, I would because careful with that stuff because it will leave you stranded if you don't double check it. And that one we'd probably have to drop the tank to view the actual fuel level sensor.
I'll be there in the summer.
What's up?
I'll be there in the summer to do it.
Yeah, sounds good. I don't know who's gonna be teaching the summer, but I think we're still gonna be running summer classes. They should be up. I'm not sure exactly just yet how that's gonna work. I'll know more information. I think maybe this Friday of what we're gonna be offering, and we'll see what's gonna happen with that. But I think by fall we should be going back to normal. I'm pretty sure we're gonna be running into precautionary measures, so I'm pretty sure we're gonna have to be using like masks and stuff like that. Maybe keeping our distance. But I'm pretty sure we'll be back to normal by fall at least. So we still got some time. And this schematic right here, guys, I want you to look at it. So we need to disable my fuel injector system, right? We're gonna disable all the fuel injectors. What would you guys do to disable my fuel injectors and why?
Check out the relay,
What relay?
the fuel relay.
Where do you see that here?
Oh shit.
So look at it, study it. How can I disable my fuel injectors? And what would you do and why?
Pulling the ECM1 fuse.
ECM1 fuse. Okay, perfect.
Mhm.
Why do you want to pull that one out?
They're all
because
connected to
one's
that.
connected to every single injector.
So what? Bless you.
Kill
What?
him.
Thank you.
Splices
My bad.
connect all of them together.
Power distribution cell. Or
But what's
the
the
fuse
splice number?
block itself?
So the fuse block, you have ECM1. You're correct. ECM1 provides power to S161 and S104. So that's your splices. Your splices is S104 and S161. S161 goes to 1, 3,
2.
2, and the splice, and 4. So we have 2 splices that go interconnected to both, which then splits 12 volts to each. What do you see here that looks exactly the same on all of them? On these wires right here.
They're all the same color wire
Why is that?
because they're going all to the same place essentially.
Yeah.
They have the same power.
Yeah, they're
Same
all
area.
handling the same power from the same circuit, from the same wires, from the same fuse. That's why they're all pink. Circuit number 439. Now, the way an injector works is why on the bottom part do we have different?
Because
How
in
do you
order
think
for
this?
the injector to inject, it needs to be ground out.
Perfect. So now your ground side of the injector, which is terminals B, 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 all these B, you have individual wires coming out of your vehicle control module or your VCM, and it's called actually an injector driver. But if you look at the injector driver, what is that symbol right there?
Ground.
Perfect. So your VCM provides a injector ground to each injector depending on what. And it doesn't show you here, but how do you think an injector is controlled?
Power.
Well, we have a constant power, and you know it's grounded out to pulsate it, but what tells an injector to actually shoot the fuel?
Isn't it fuel pressure?
Not fuel pressure. How do you determine? Think about it. Your combustion engine has to have 3 things. It has
The
air.
distributor.
Okay, so does this distributor have any type of sensor on it?
No.
So there's got to be some type of sensor because yours is already an advanced engine because it has electronic ignition with a distributor and it has electronic fuel injection.
The
Back in the
VCM.
day, well, not quite. I don't. It doesn't show it here. I want you guys to think outside the box. Because think about it. Let's go back to carburetors. How did carburetors work? How did it work back in the day?
Fuel.
You had fuel coming out of what? A carburetor, right? And how did the carburetor work? It was just
It literally
It was
dumped
just
fuel
power.
into the
Yeah.
air and it sucked it in.
exactly. It just dumped fuel into the intake manifold, and when the piston was coming down, the actual piston was sucking up air and fuel, and then you have an ignition. But it was actually timed with your distributor and your ignition. But the fuel was not controlled by a computer. It was just controlled by gravity and the vacuum from the piston. So that's all it was. So that was simple. Now, when we get into more advanced systems like this, we have an electronic distributor as well as an electronic fuel injector. But what tells my fuel injector to properly pulsate fuel into my combustion chamber? That's what I'm trying to have you guys figure out. What tells injector 1, 3, 5, 7, 2, 4, 6, 8 to pulsate? What do you think that is? Anybody? I just hear crickets.
I think there were birds.
No?
I'm
Nobody?
back. Sorry, I missed the question.
What tells my injector when to pulsate?
Probably an electronic signal from the vehicle control module.
Yeah, there has to be some type of signal. And normally it's the signal coming from either a crankshaft position sensor or a camshaft position sensor. Because this is going to tell my vehicle control module what position my piston is in. If it's coming down for a downward stroke, which means it's already sucking up air, then more than likely I'm going to want to shoot fuel into that because it's coming back up for a power stroke. Does that make sense?
Yeah. Does the knock sensor have anything to do with that?
No, the knock sensor just it pretty much notices any type of pinging or knocking coming from your engine. Because if there is knocking or if there is pinging, what it does is it actually retards the timing to prevent any damage to your engine.
Is
But
that why?
Go
Because
ahead.
when they didn't have it on,
Mhm.
like my sister would use my sister was using it for a while, and then she would like drive it everywhere, and then
Mhm.
one day it just wouldn't start at all.
No, I don't think the knock sensor will prevent an engine to start a
I mean, unless the
Camshaft
ducting is that bad.
If it's that bad, maybe, but
It just
normally
causes
it
poor
doesn't.
fuel economy.
Yeah, it causes poor fuel economy and lack of power because you're not
So-
able to advance.
Ever since I put it on or been working on it, it hasn't.
Doesn't turn
It
off, right?
hasn't. Yeah, been doing
Well,
good.
I think remember when we were checking out that switch. I think the reason your car was turning off or not turning on at times was part of your ignition unit.
Was it
remember
because
The resistor.
the resistor?
Yeah, because the resistor was pretty much bypassed. On your system, you had a Passlock 2, which is an older GM security system, which
Yeah.
used an internal resistance in your key. When you insert the key into the ignition, it senses this resistor and it matches it up with its database. If it does not match, it will
Would it
not turn
have been
on.
like loose or something?
It could have been, because I think remember I asked you to solder it, right? To see if it had a better
I
connection,
soldered it and both.
and it hasn't failed.
Good
That's
thing
good.
for now.
Hopefully that's it for now. The problem with that is it's 99. So OBD2 was still pretty fairly new. OBD2 came out at 96. So if there's a problem, we would have to look it up on the actual OBD2 scanner and see what type of system information it would give us. The good thing about new modern technology and new modern vehicles is the computers have become more advanced, and it's actually able to give you um, information that the computer is either seeing or is not computing or something's wrong with the data, which is easier for us to actually diagnose the circuit. So that's the really good part about that.
Because when you
Uh,
think about it, computers are literally just millions of ones and zeros, and the computer can read that very quickly and tell
Exactly.
you when that one should be a zero or when that zero should be a one.
Yeah, and if it doesn't match up, well then it triggers a code and it tells you, hey, I need you to check this out because something's going on. Something's not computing correctly. It's amazing. I think computers and the way that we're going is pretty amazing. But it's also, I think it benefits us as a technician because it helps us diagnose the vehicle easier and better. The hard part of it is, if you've noticed, electrical is not going anywhere and it's getting more complex. This is a 99 and it's already a pretty intensive diagram. It's not that bad. I mean, hopefully we can actually see it and understand it. But if I show you something from like a 2019, 2020, it's going to be completely different. Not only because of that, but if you've seen these new vehicles, they actually use dual fuel systems. So they have 8 port fuel injectors like this, and they have 8 direct injectors. So you have, what's up?
Can we do a schematic on one of the new ones?
Yeah, I'll pull one up right now. Let me just show you guys on the things we would have done for the starter, and then I'll pull up a new system. So, if we're going back to this job sheet, oh, this is my homework. Nope, this is not it. Nope, not that either. Is this one? Yeah. So what I want you to do is, this was the job sheet we would have done in the actual class, is I wanted you to do a voltage drop on the cables that connect the starter motor. So all test results should be less than 0.2 volts, which is 200 millivolts. Now remember, anytime you do a load test, it has to be loaded. So how do you load a starter motor? Anybody? Yeah, ignition on, but you actually have to have it cranking to load up that motor. You load up those circuits by cranking over that starter motor. So on here, where
How
is
would you
my starter
crank
motor?
it without starting the engine?
Yeah, you have to crank it without starting the engine, and that's why I had you guys look up this guy. I want you to disable your injectors so you will not be dumping fuel in the actual combustion chamber, because if you did, you'd flood it and it would cause more problems. So right now, we have the starter motor schematic, and I want you to show me
It's down
or
here in the
tell me.
bottom.
So the starter motor is right here, right?
Yeah.
Okay. So now we
I
have
feel like I'm watching like Blue's Clues. It's down there.
find. Oh, that's too funny. Where would I do my voltage drop for my starter motor? Now I want you to tell me the circuit number, the color, and where do we check it from where to what? Remember,
6 and 1.
where?
on the black and the purple PPL. No, never mind.
Anybody? So our starter motor's right here, right? Now I need to do a voltage drop on the cables.
On the ground of the motor, no?
Okay, so you said here
Yeah.
to where?
To the black,
Where?
the black 132.
132, 132.
He's talking 32 black one.
Oh, so that won't work because what is being provided at
Oh,
32
shit.
black? Look at this. This is your battery, right? This is your battery. So what's down here?
Ground.
Ground, right?
Would it
So
be
this is ground.
the 3 PPL 6
3 PPL6. Where's that?
on the other side of the black? Nah.
Okay.
No, it's not.
So that is power, but that's not your heavy duty circuit. I want to test my heavy duty circuits, our thick gauge wire, the one that's actually giving power to my starter motor to rotate.
Okay, is a battery stud now?
What's up?
Just keep on going straight on 19 red. It says battery
19 red,
stud.
19 red.
Straight
So
north.
okay, so if you look at here, that is this one.
Yeah.
Is there red? Yeah. There's this one right here, right? Red for
Yeah,
power.
go straight up.
Okay, but
Straight up.
where does that go to?
That's
Under the fuse block.
battery stud.
Yeah. So is that the one providing power to my starter?
Stephen was right. Providing power to the starter is 32 black one. It's just
It
going
would
up
be
to the
this
left.
one. Yeah. So it's this one.
I knew it.
Because this starter cable right here actually splits up into the underhood fuse block as well as starter solenoid. So this is your main one. So how do I check this circuit from 32 black terminal 1 all the way to my battery right here using my digital multimeter? How do I check a voltage drop from there to there? Where do I place my red lead?
On the red.
So you want
Power,
okay, so here too.
battery power. Black lead on the end of 32 black one. And then set it to volts DC.
Volts DC.
If the black is also the power, why are you putting the black on the black?
So right now, remember, we're doing a voltage drop. Right?
Okay.
Yeah, so it's a little bit different. We're not checking for voltage. We're doing a voltage drop. Wait, no, it's not what I want to do. Alright, so
Dude, I hate it when my sister's doing sketchy shit.
like what?
I don't know. Well, it's because one, she already told me what she wants to do, and well, I already went with the plan, and the thing has been bought.
Uh-oh.
So I'm gonna dye my hair,
Oh shit.
and right now she asked me black and gold or black with silver. I'm like, black and gold sounds better. I'm like, wait, for what? She's like, don't worry about it. I'm like, oh, come on.
All gold, dude. Do it all
Yeah,
gold.
things messed up.
That's funny.
Gold member.
So on here, once we have it set up, of course, you need to go underneath the vehicle to get to the starter and on top to get to the battery. You now need to crank over the engine without the vehicle actually turning on. So we're checking the voltage drop from
Hey, you got 100 bitch.
here to here to here. What should your result be?
Less than 0.02, right?
Yeah, less than 0.2 volts, which is 200 millivolts. If it is less than 200 volts, 200 millivolts, your connection is good from your power to your power. Now, how do you check the ground side?
Same way.
Same way, but where at?
32
Uh,
black one.
So we already did the power side. Let's say our results were we got 0.125 volts. That looks good. I think that passes. So now we got to check our ground side. Now, how many grounds do you think we need to check?
2.
Two? Does everybody agree on 2, or does anyone say anything else?
Hold on, my side.
what
I
about
think
sure?
one?
2? 1?
One.
Nobody else?
For which one?
So,
The 32 black one.
Oh,
me,
it's
personally,
gonna be 1.
I think so.
Yeah, because it's connected to. There's a splice with the ground distribution cell.
So you have a ground at G105. You have a ground at G101. But,
Oh,
what's
shit.
this?
Ground
Where is it grounded to?
to the body.
Yeah, to the actual engine block. So what I would do is I would check 3 ground areas. So yeah, it's a it's a little more different, right? So now
I didn't even
on
see that.
here, what you would have to do is, let's just say, red lead on your ground terminal right here, right there, and your black lead needs to go. Let's do the first one, G101. If the result is less than 0.2, that is good. Your next one would be here
The
to
one.
G105.
Yeah.
Let's say the result is 0.352 volts. Okay, so I would say there's a problem here. And our last one I would check is the actual case where the starter's mounted at, right there. And that is a result of, let's say, 0.15. So let's say the customer came in, the customer says, hey, it has a slow crank. And we checked all the results. We had 125 here, that's good. We had 0.2 here, that's good. We had 0.2 here, that's good. But here we had 0.352 volts. Where's your problem?
The G105.
So your problem is going to be from G105 all the way to your ground cable right here. So where the hell is G105? What do you have to use to find G105?
Follow it.
Google it,
Follow it.
follow it,
Just
Or-
follow the wire.
let's look it up. It's a 99, so I'm not sure it'll show it to us, but let's see. It should.
Is it on the battery?
One of them is attached to the battery. The other one we have to find. So we're
'Cause I
looking
know
for.
I have one that's on the frame, on the bottom, the starter. And
It might be that
then
one, actually.
there's- Yeah.
But we have to always be 100% sure.
No, because the one from the start, I think that doesn't go.
Right here, G105 for your
Alternator.
vehicle, it says on the right front side of engine block. And it is number 1. Oof, we're way off. Look at that.
Where's it at?
That's right there.
Oh,
That
shit.
is your ground. On your left side of your engine block attached to the actual block. So now, do you think this is an important one? What's up?
Yeah.
I'm gonna go check it out.
Go for it. Take a picture if you can.
Okay.
You see that right there? G105? This is your starter. So think about it. This cable on my schematic right here, G105. Can y'all see that?
Yeah.
Where is this attached to?
The block.
The block.
The block and then?
The starter.
No, not the starter.
It's a battery.
The battery. So if think about it, guys, really think about it. If this cable is attached to my battery and if this is loose or corroded or high voltage drop, do you think my starter is gonna get a good ground?
No.
No. So can that be a big problem?
Yeah.
Yes. It's there. Can you send a
Yeah.
picture on Discord?
Yeah, but yeah.
You see, so that's why I'm trying to put all these things together. Your schematic, your component views, everything. Your all the stuff we're doing. I'm trying to put it all together so you guys can actually visualize it. If this ground G105 has a high voltage drop, you can pretty much see. Where's it at? On this schematic, that ground is directly from my battery. My battery is the one that provides the power ground for the whole unit. So if you have a high voltage drop on that one circuit, you're going to have problems with your starter solenoid, your starter motor, because your starter motor is connected to that block via G105, as you can see on this diagram right here. That ground right there goes through one of these loops back into your battery. Your starter's grounded out to your block. Without that ground, you're going to have a lot of problems. And I'm telling you, voltage drop is one of the biggest things that people have issues with because they forget how to do it or they forget what you're actually testing. Just understand what we're actually looking for. Was Steven able to send us a picture? We'll wait on that picture. Let me just show something really quick. There he is. Were you able to get a picture, Steven?
I said I don't have access to some shit. Hold on. It says you do not have permission to send messages in the channel.
What?
I mean, what channel are you trying to put it into?
This on the archive.
Oh, put it on the general.
Oh,
Yeah, go to general.
there it is. Never mind. Don't worry about the grease, guys.
There it is. That's G105 right there.
The little thing you see, right?
Yeah,
The
that
little
stud
screw.
where it's at. That's your ground right
Yeah.
there.
Nomás limpiándolo bien.
Yeah, shit. Good to go.
Ahorita voy por el car wash.
Trying to find. Oh, buddy, someone's cracking open a cold one already.
Ooh, yo. Yeah, it's my second one.
Nah, they don't have them. I'm trying to find a fuel injector system with dual fuel injectors. I know Ford has them. GM,
Yeah.
I think, only has it on the Corvette. I think it's the new one. Let me see.
También, what's that fucking?
Which
Audis
one?
have them too.
Audis, yeah. A lot of them have them.
What's it, that A5?
Yes. They have dual.
Supposedly, what I heard that they share a lot of parts with Lamborghini.
Damn. They might. Shit, I wouldn't doubt it.
Like their heads, well, they had their turbos también.
That's about us.
The block.
Fuel controls.
Oh shit! I got
No, not this one. Maybe the 2020? Do I have a Corvette 2020? Oh shit, I do.
the C8 probably.
It might. I think the 2020 is a Corvette C8, right?
Yeah. Algo que sea front wheel drive.
Yeah, it's not showing me a dual injectors. I know most manufacturers are doing dual now. But if you look at this is a 2020 LT2 Corvette. Now if you look at this compared to the 99, what do you see different on a 2020 here versus a 99. This is a 99, and this is a 2020. What is different?
Ignition coil.
Not remember, this is the injector, not the coils. But what do you see different? How are these guys controlled on the new engine versus the older engine?
Different wires.
Okay, well, of course we have different wires, right? So look at them. Look at 99. How is this injector controlled? Oh shit, sorry. No, I didn't mean to close it.
The the 2020 doesn't it?
Does it have what?
It has relays on it, the 2020.
So okay, yeah. So look at this. How is this injector controlled? Like how is this guy controlled? It's an electromagnetic device. How is it controlled?
I said I wouldn't help.
The BCM
Okay, the ECM provides what?
ground,
Okay. So then does it have a constant power or constant ground on here?
constant ground.
No, you have a constant power. Your ECM provides power through the splices, so you always have power at A on the injector all the time. What you're being provided by the VCM is ground dependent on when it's being driven. Okay? So that's constant power, commanded ground.
Oh,
On
okay.
the 2020, what do you see different? These are all injectors. How is it being controlled?
Constant power.
Are you sure?
No.
It doesn't. No, it's
Can you like scroll up a little bit? Or it doesn't matter.
No, this is the high pressure pump, and it's you don't need that. Yeah, so you need to see this. How does this? Let's say, look at injector one. Remember, focus on one. Fuel injector one. You got ECM. You got terminal 1, terminal 2. So it just needs two things, right? Like everything else. What do you think it is?
Power and ground.
What do you think this is?
Power and ground.
Power and ground. So your ECM can now activate through internal driver switches, power and ground.
But the ground's not connected all the time.
Yeah, exactly. So you actually have normally open switches inside of your ECM. It will only close when the injector is commanded by your computer due to several sensors.
Is that why sometimes it runs like on 4 and shit like that?
Exactly. That's why they did this.
shit,
Yeah.
okay. Now
So now this new engines actually have a V8, V6, V4, modes, so they can actually run on 8 cylinders, 6 cylinders, 4 cylinders. Actually, Chevy has a system called dynamic fuel management where it can actually run on 1 cylinder. But it's able to alternate that cylinder to keep balance of the engine by alternating the injector from 7 to 1 to 6 to 8 to whatever it needs to be. And that the way it's accomplished is your ECM can now drive both power and ground through 2 circuits to command an injector more precisely, depending on what is needed. Does that make sense?
Pretty cool.
Yeah, it's a complete different change from a 99, which is you have constant power and your computer provides ground.
That's why it wastes a lot of fucking gas, right?
It might. It's also it could be that could be one of the reasons.
It's
Because
destroying
on
the fucking
these,
gas.
yeah, it's just dumping gas when it needs it, and this one you can actually control on where it need to be specifically, and that's where all these sensors come into play. But that's what I wanted to show you guys on the new 2020s. I'll try to find one that has dual fuel systems, which is going to be port injecting as well as direct injection, and I'll get a schematic and I'll show you that. If this one was a dual fuel, you would have 8 direct and 8 port, so you have a total of 16 injectors on one engine. It
would it
is
run off the same fuel pump or
yes.
just a
The
big
low
one?
pressure side for the port fuel would run through the low side fuel pressure, and on this one, so this is direct injection, you actually have another pump called your high pressure pump. So
Oh, really?
this one would have two fuel pumps,
That
but one
Vega.
is driven mechanically. What's up?
This shit, fucking Electude's taking away our fucking from learning this shit.
I know, and that's why I try to do a schematic every time we meet, because this is the stuff that we need to focus on. That's why every day I try to put at least one schematic so we can review it and test it and check it out and see what you're looking at, because this is the tough part, is understanding the schematic to see how it works.
This is
Because
more
if I have
fun.
yeah, I love this stuff, man. Now, if I had, let's say, like this is my first time I've ever worked on a 2020, and I don't know exactly how it works. And as I've told you before, look at the description. Is it gonna go? Always look at the description operation if you don't see what it is. Let's go to fuel system, fuel pressure, fuel level, fuel injectors. So the fuel injection system is a high pressure direct injection returnless on demand design. The fuel injectors are mounted in the cylinder head beneath the intake ports and spray fuel directly into the combustion chamber. Direct injection requires high pressure due to the fuel injector's location in the combustion chamber. Fuel pressure must be higher than the compression pressure, requiring a high pressure fuel pump. The fuel injectors are also required more electrical power due to the high fuel pressure. The ECM supplies a separate high voltage supply circuit and a high voltage control circuit for each injector, which we saw on the schematic. The injector, high voltage supply circuit, and the high voltage control circuit are both controlled by the ECM. The ECM energizes each fuel injector by grounding the control circuit. The ECM controls each fuel injector with a 65 volt. This is controlled by a boost capacitor in the ECM. So actually, we're not working with 12 volts anymore. So it actually boosts the voltage to 65 volts to open up the pintle in the injector. This is controlled by a boost capacitor in the ECM. During the 65 volt boost phase, the capacitor is discharged through an injector, allowing for initial injector opening. The injector is held open with 12 volts. So the fuel injector assembly is an inside opening electrical magnetic injector. The injector has 6 precision machined holes that generate a cone-shaped oval spray pattern. The fuel injector has a slim extended tip in order to allow the sufficient cooling jacket into the cylinder head. So that is a lot to take in with just one schematic. So it's crazy, guys. I'm telling you, I push this a lot on my engine performance class. If you have me again for engine performance, I'm gonna have you guys do all the research before you start doing any of the job sheets. Research means you understand how it works, you read how it works, and you explain to me how it works before I have you guys test the actual circuits. And that's how I do it on engine performance, because engine performance is more specific particular things. So
I
just
think I
be
might have
aware
it
of that.
for engine performance.
Yeah, usually it's like one of the last semester courses. I've been teaching it for quite some time already. I love it, but I do ask for more. I do ask for schematics. I do ask for connector end views. I ask for component end views, and I ask for description operations. And I don't let you continue until you tell me how it works. Summarize how it works. Once you summarize it, and once you tell me, then you continue and show me how to diagnose it. So I get
Sounds
a little
good.
bit more specific on that, but it's good. Trust me, I'm telling you, because this has helped me as
Technician.
a yes, exactly, as a diagnostic technician. Understanding what we're looking at, understanding how it works, makes you test it a lot easier, or understand why it's actually failing. So that's what I do on my engine performance. Just a heads up if you have me again. For electrical, I do need you guys to understand, of course, the basics of electricity, understand the schematic, understand how to use a DVOM, and so on. If you do have a DVOM with your on you, go out there, work on your cars, do some checks, do little things here and there. Don't forget, of course, I know it happens. Usually when we turn back to school, I take around a week or a couple days to actually review a lot of the electrical circuits, voltage drop, available voltage, resistance, etc. Everything on the first couple, maybe a week and a half of actual electrical information because you will need it for engine performance.
I was
So,
trying to
Uh-huh.
trying to fix one of my grinders with that the multimeter,
Uh-huh.
but like fucking like because at one angle it works and the other angle it doesn't.
So maybe it's the switch.
It's getting power, so
So it rotates only one way or it doesn't rotate the other way. What do you
like
mean?
if I put it at an angle, it'll fucking
Huh?
work, and then I put it flat and it's not
Oh,
working.
it's probably a loose connection on one of the wires.
Yeah,
You might want to use your digital multimeter and check the wires. I think it's only what 3 maybe going in.
because I
Check.
checked those and
Uh-huh.
I checked for
Yeah,
can't
continuity.
fucking say it. Yeah, I checked for that, and
But did you move it around? Did you do the wiggle
Yeah.
test?
It like fucking beeps and shit.
Hmm.
But
Somewhere
you know
along
what?
the line.
Actually, I had taken off the clips, the fucking connectors,
Mhm.
and then I put them back in, and then I tried it, and it was fucking working fine.
That's weird.
And I put it, and then it stopped. It started doing it again.
Yeah, I'm pretty sure there's a loose connection in maybe it's internally or maybe it's at the switch because the polarity is usually switched through the actual switch itself. If you have the meter, I would check the wires end to end and do a wiggle test, so pretty much just move them around and see if that beep goes down, or even check the resistance because if you have a loose connection or if it has loss of connection, it will not work at some angles, like you said, because more than
Yeah.
likely it's opening and closing the circuit. But yeah, use the stuff that you're learning here to apply it to your. I mean, electrical is going to be the same. The only
Yeah.
difference between that is going to be it's controlled by a 110 voltage AC rather than 12 volts DC here. So
Gonna
don't
hurt
check it
more.
when it's plugged in. Always disconnected.
It's gonna
I was
fucking
gonna say,
hurt
in
more.
order to test my inverter, I have to actually power it.
Uh-huh.
It is
Oh,
the
really?
scariest shit
Oh no.
because it outputs at I think it's 240,
Oh yeah, that's a lot.
and it's scary because I had one wire that was like really jank, and
Mhm.
ended up touching one of the capacitors.
Oof.
Thankfully, I wear a face shield when I'm working with it.
Yeah, you gotta be careful with that stuff. I mean, and I've worked with 140. I mean, sorry, 110, 240. It's not a big deal if you know what you're doing, but always take precautionary measures. Like John was working on it live, but he had to work on it live because he had to find out what was going on. That's fine, but make sure you use the correct methods. You know what I mean? My
So
grandfather. Go ahead.
that's why I just bought a fucking new one.
Yeah,
Fucking-
yeah. I mean that works too. Remember, my grandfather would he'd show me some stuff around the house. Like, oh look, you want to make sure. Yeah, like I was thinking he's gonna show me a tool. He pretty much just touched the wire with his finger. It's like, oh, see, this is warm. This is hot. I was like, oh hell no, I ain't gonna put my hand in there. Fuck that. He was crazy, dude. But I was like, nah, I'm gonna buy the correct tools to do the correct job. And there's little meters that will actually check if there's AC current passing through that wire. If there is, you need to turn off the wire and turn off the breaker, and then check it after that. But yeah, it
like
was crazy, man.
my dad had a fucking extension cord,
Uh huh.
fucking three different ones, fucking
Uh huh.
taped together and shit.
Oh no. I
Nah,
I had an
fucking threw
extension cord that kept popping my breaker, and it was like a 100-foot cord. And sure enough, I found that internally somewhere it was cut. So anytime I would load it up, it would touch ground and it just pop a breaker right away. So I had to open it up, refix it, and I got it going again. But because they're expensive, man, those cables are freaking expensive. I was surprised.
Yeah.
But I guess that's it for today, guys. Hopefully we got to do some things. We did some electude. We did some job sheets. We did schematics, a little bit of review. If we have any more questions, like I said, shoot me up on Discord. And Monday we'll do some more stuff. We'll go over electude again if we need to. We'll go over some more schematics, and I think we'll be starting alternating systems. Just finish up your chapters 6 questions and your electude, and we'll continue from there.
All right.
Alrighty, guys. Y'all have a good rest of the day, rest of the week. And like I said, if you have any questions, just let me know here.
Sounds
Awesome.
good.
Alright, guys. Y'all be careful.
All right, bye.
You too.
Bye.
Enjoy yourselves.
Me too. Be careful.
Stay active.
Yes.
Yes, definitely.
Definitely.
All right, later, guys.
Later, guys.
Later.